Hello, welcome to Trends.Earth training. Thanks for joining us. My name is Gabriel Daldegan. I'm the land system scientist with Moore Center for Science at Conservation International, and I'll be showing you how to use Trends.Earth to track change in land condition using geospatial data, whether you are using freely available global data, default data, or local data for your specific region of interest. Let's get started by installing Trends.Earth plugin to QGIS. Please note, to do that, you will need to have QGIS version 3.22 or higher already running on your computer to be able to install the latest version of Trends.Earth. So I'm going to open QGIS, and I'm going to show you there are different ways to install Trends.Earth, depending on whether you want to install the stable version, which we recommend, or install the development version. First of all, I'm going to show you how to install the preferred way, which is the stable version of Trends. So here on QGIS, you can come up to the menu toolbar and click on Plugins, and then Manage and Install Plugins. This is going to open a new dialog. Here on this Plugins dialog, what you have to do is click on All and type Trends, and this is going to show you the stable version. Then you can click on Install Plugin, and it's going to have it installed on your QGIS. But I'm also going to show you how to install the development version. So here under the same plugins dialog, you can come to Settings, and then click here on this checkbox to show also experimental plugins. Once you've done that, you can come back to Trends.Earth to all the plugins and search for Trends. And now you're going to have the option to install the experimental plugin by clicking here. And there's yet another way to install the development version of Trends.Earth. So what you have to do is go to Trends.Earth webpage. And here on the left-hand side, you're going to find the development option. This is going to show you a link to Trends.Earth GitHub repositories. So here you can click on this option here, and this is going to open our Trends.Earth GitHub, and then you can scroll down, and here installation of development version of plugin, you're going to have all these instructions that I'm showing you, and then you can download the latest Trends.Earth zip file, and then go back to QGIS under plugins. On the same dialog that I showed you before, you have also the option to install from zip file. So I'm going to click here on browse, navigate to where I saved the QGIS zip file, and please note the zip file is going to have this name, ldmp_QGIS3. And then I select this file, I open, there's no need to unzip it before, and then I just click in Install Plugin. After a few seconds, we're going to receive a confirmation that the plugin has been successfully installed. Once you have installed Trends.Earth, you can close the plugins dialog and look for Trends.Earth plugin on your QGIS project. Here, you can click on this drop-down box and hit Settings so you can register if you have never used Trends.Earth before. So here, you can register for Trends.Earth by entering your email address, your name, your organization, and the country where you are. Once you hit OK, go back to your email address inbox, which you used to register, and look for an email from API@Trends.Earth with your password. Once you have your password in hand, you can come here to this other option, enter username and password, and here you enter your current username, and you can enter your password that you have just received from our API. Once you successfully logged in, you're going to have the option to also join the Trends.Earth users email group, which is a community discussion group where users have the chance to ask and answer questions about Trends.Earth. Once you have logged in, Still on the same settings dialog, scroll up to select the region of interest. Here, you're going to have a few options. You can select a country or region from the drop-down list available. You can also select a specific region within the country of interest or a city within the country. You're going to also have the chance to manually enter coordinates for your point of interest, or even bring a shapefile, a KML, or a GeoJSON representing the area of interest. We recommend applying a buffer, a small buffer, around the point, the coordinate point that you use, the city that you use, or area from file, just to make sure that there's no geometry inconsistency when reading that file. Once you are done with that, you can also have the options, advanced options here down below the same settings dialog. Here, you're going to have the options to select where in your computer, which folder in your computer you want to store all the data that is going to be output from Trends.Earth. So you can select here and go to a specific folder in your computer. But by default, Trends.Earth is going to create this Trends.Earth data directory on your computer, on the root of your computer. Other advanced options that you're going to have is also to filter remote jobs according to the region of interest that you want to that you have set up. You can also enable the debug mode. You can check and uncheck the download remotely generated datasets automatically. And if you have this checked, you can also control how often you want the Trends.Earth to communicate with the server and download datasets. So we recommend, if you have issues with internet connection, we recommend unchecking these boxes so Trends.Earth is not going to be trying automatically to connect with the server, which could generate some issues with internet access. Okay, so now we have selected our region of interest and the advanced options. So we can hit OK. And now let's click on the Trends.Earth functionalities. So once you click either here or on the icon, this window is going to open on the right side of the canvas. Here, you're going to have two tabs or two windows. One is called Algorithms, and the other one is called Datasets. So under Algorithms, you're going to see all the functions that you have available through Trends.Earth. So let's learn how to generate the subindicators for SDG 1531. So here, under SDG 1531 Land Degradation, we have a few options. The first one is subindicators for SDG 1531. Calculate SDG 1531 subindicators in one step. So we can click here on Execute Remotely, and a new dialog is going to pop up. On the SDG 1531 indicators in one step window, I'm going to have the chance to generate all subindicators in just one step. So here, users have the chance to select either the Trends.Earth land productivity or the land productivity dynamics from GRC. The GRC one featuring 1 kilometer spatial resolution, and the Trends.Earth featuring 250 meter spatial resolution, given that it is derived from MODIS imagery. Then I'm going to select the period for baseline. So if I'm selecting the Trends.Earth, for instance, I'm going to use the 2001 to 2015. But I could also select different time series for each of the subindicators. But I'm not going to do that because I'm assessing baseline period here. So all the subindicators should go from 2001 to 2015. And then what I'm going to do, I'm going to also include the progress period. This time I'm going to do this for, I'm going to allow a different time period for each subindicator. So for land productivity, I'm going to use 2005 to 2019. And then everything else I'm going to use to 2015 to 2019. And I have again the chance to see which region of interest I'm running all this analysis. So here is for Colombia, all regions, but if it was a different region, I could click here on change region, and then the settings dialog is going to come up again. So you could modify this easily here. But it looks right, so I'm going to go ahead and hit OK. And then what I'm going to do is just give it a name. Then I have also the chance to add the land cover classes definition. So the default land cover dataset is the European Space Agency CCI dataset representing land cover classes for the entire world at 300 meters spatial resolution. And then we have the original input code or input classes. So we have 20 plus different land cover classes on the ESA CCI dataset. And then what I'm going to do, I'm going to match the original input class to the one of the 7 land cover classes recommended by UNCCD. So here, for instance, cropland, I'm going to select cropland. For herbaceous cover, I'm going to select as grassland, and so on. Once I'm satisfied with my modification, I can save this definition to file. So later on, I can just load this definition from file and save time. If I'm not satisfied with this definition, I can always reset the table to default. Once I'm done, I'm going to hit save on this dialog, and I'm going to move on to the land cover transition matrix. Here, we establish the relationship between the initial land cover class with the final land cover class for the target year. So, for instance, if a tree covered pixel at the initial year changed to grassland, it's going to be indicated as a degradation. So we have the purple color here indicating degradation and also the minus sign. And same for cropland, for wetlands. So a pixel or land that was mapped as tree covered and changed to any other type of land cover class, it's going to indicate the degradation. But this could be easily edited by users just by selecting the cell to each and then clicking on plus sign, for instance, and then this relationship is going to change. And here again, I have the chance to reset the table. And if I've made modifications to this transition matrix, I can save this to a file and then once again load this saved table and save time later on. Once I'm satisfied with all the arguments, the input arguments here, I'm going to hit schedule remote execution. And then we're going to see this blue ribbon telling us that this task has been submitted to Google Earth Engine. In case you don't want to run all the subindicators in just one step, but you would like to have more control to set up the parameters for each of the subindicators, we also offer you ways to calculate each subindicator of SDG 1531 individually. So still under SDG 1531 land degradation, we just ran this option to generate all the subindicators in one step. If you scroll down a little, you're going to have the options to run land productivity, land cover, and soil organic carbon individually. So let's first focus on land productivity. So by clicking on execute remotely, this new dialog is going to pop up. Here, you have the option to select the Trends.Earth land productivity derived from MODIS imagery, or you can also select the UNCCD default data, which is the land productivity dynamics coming from the GRC. Let's select the GRC LPD 2000 to 2015. Again, we have the chance to double check the area of interest. And if you're not satisfied, you can click here and change the region of interest. And we're gonna give it a name. Here, what you have to do is just hit schedule remote execution, and this is going to be submitted to Google Earth Engine. But if you would like to explore other options, you also have the chance to select the Trends.Earth Land Productivity dataset. And here, you're going to have more control how this indicator is going to be generated. So you can select which NDVI dataset you would like to use, the AVHR at roughly 8 kilometers of spatial resolution, or the MODIS dataset in pretty much 250 meter spatial resolution. Here, you're going to have the option to select the trend, the land productivity trend. You can also pass some corrections. Here we have different methods, and you can click here on this option to learn on this URL to learn more about each of those methods and how the SUM indicator for land productivity is calculated. And then you can select the 2001 as 2015 as the time series of interest. And 2001 here is because the MODIS satellites were launched on 2000. So there's only for 2001 we have full data available for the entire year. Here you can also, if you select to correct by climate or by precipitation, you're also going to have some options on which data set representing global precipitation you would like to use. So make sure to explore all the options you have to calculate the indicator, the trend indicator, and also which data sets you have available to perform those corrections. And of course, if you would like more details, here we have description, but also hyperlinks to our websites where you can read all the details about each of these methods and data sets. So for performance, I'm also going to use 2001 to 2015. And for state, I'm going to be using 2001 to 2012 as the initial period. And the comparison period is going to be 2013 to 2015. So once I have set up all those input arguments, I'm going to select schedule remote execution. Once again, we see a blue ribbon telling us that this task has been submitted to Google Earth Engine. And this is also going to show here on the datasets window that this task is currently running on our server. You can repeat the same steps now to calculate the reporting period. So let's do it again. So land productivity, now from 2005 to 2019, same region. And then again, you just enter all the information here and hit execute remotely, and you're going to see a data set for the reporting period as well for land productivity. So let's now run the land cover change, also executing it remotely using the default data coming from ESA CCI dataset representing land cover at global scale. So here, given that we are calculating the land productivity indicator for 2001, starting in 2001, I'm going to leave it also 2001 to 2015. It's also running it for Colombia. So I'm going to give it a name. And on this function, you also have the option to edit the land cover change matrix. So pretty much the same thing as we saw during the running all the subindicators in just one step. And you also have the chance to save if you, by any chance, you change some of the positions here. You're going to be able to save this, but I'm going to use the default transition metrics for land cover. So now I have the initial year, target year, execution name, and my notes. I'm going to hit execute remotely. Once again, we're going to see notification, and we can check under datasets window that now we have a SUM indicator running for land cover. And you can, again, run land cover subindicator, this time only for the reporting period. So let's say 2015 to 2019. Again, give it a name, check if the transition matrix is what you want, and just hit execute remotely. And now let's do the soil organic carbon subindicator individually. So we can click here on execute remotely. This new window is going to pop up. Again, I'm going to run it for baseline. So here I have the options, the chance to set up the initial year and the target year. And we can again have control over how we match the original land cover classes coming from ESA CCI land cover class dataset to the 7 classes, land cover classes recommended by UNCCD. Once you are satisfied, you can save this definition. If you have added it, you can save this definition to a file and later on load it, or just reset the full and let's check the region of interest, and still for Colombia, and this time is SOC indicator using for baseline. And if you scroll down here, once again, you have advanced configurations. And here you have control if you want to use the default factors or coefficients to apply to each change in land cover over time, or if you would like to specify a regime, picking one of the pre-populated coefficients here, depending if you are on a temperate or tropical, and also on a moist or dry landscape. Or even you can also manually type in a coefficient that you have and that you know that it would be more appropriate for your region of interest. You can also check the option to download annual land cover layers that would be that is going to be used to calculate the changes in soil organic carbon over time, applying these coefficients. And you can also set up an initial soil organic carbon data set in case you have that. And again, you have a description here on how the soil organic carbon subindicator is calculated. And you can also click on this hyperlink to open our website, where you're going to have full description of how this SOC subindicator is calculated. And here you also have the land use coefficients applied by default. So if you have any doubt on how to calculate subindicator, you can check our website as well, and also the UNCCD website. Once you're done with this input arguments, just click on schedule remote execution, and you're going to see the notification. And we also going to see that this has been submitted to our Google Earth Engine for calculation. Okay, so we just saw how to calculate all the subindicators in just one step, or if we prefer running each subindicator individually for our area of interest. So let's now check how our jobs are doing, if we have anything finished already in Google Earth Engine. So we can see here that my subindicators in one step are done on the server, so I can click here to download those data sets from Google Earth Engine to my local machine. And I'm going to also do that for the baseline period as well. So this is going to take a few minutes, depending on your internet access. So right now it's downloading everything from Google Earth Engine to our local machine. Once Trends.Earth is done downloading everything from our GE from Google Earth Engine, we can click here on Load Dataset onto QGIS and select Add Default Layers from this dataset to map. So this is going to load all the fault layers for progress, and this one is going to load all the fault layers for baseline. So let's click here again. So now we have the spatial layers for baseline and also for reporting period. So what we're going to do, we're going to integrate all the sub-indicators both for baseline. So we have soil organic carbon, land productivity, and land cover. We're going to integrate them to the final 15.3.1 indicator. So here on the algorithms window, under SDG 15.3.1 land degradation, we have seen execute remotely for sub-indicators and how to calculate sub-indicators individually. And now what we're going to do, we're going to integrate all the sub-indicators into the final 15.3.1 SDG. And this is going to open this new window where we can select all the sub-indicators that are going to be integrated into 15.3.1. So for the sub-indicators, one step, we use the land productivity dynamics. So let's select land productivity dynamics here. And now we have the baseline data set. So let's make sure that we have Colombia, and here is showing the progress. So we don't want the progress here because this is the baseline one. So let's do baseline. And then once we select the baseline data set here, Trends.Earth is going to match the productivity, the land cover, and the soil organic carbon data sets for these three fields here. And we also are interested in calculating the exposure of population to degraded land. So let's calculate UNCCD strategic objective 2.3 here. So let's include population data set. So this is going to give us the amount and the percentage of male and female population exposed to degraded land. And let's not forget that we are also interested in running this for the reporting period. So let's check this box here and make sure that for here we select the progress data sets. So once we've done that, Trends is going to automatically populate these other fields with also the progress geospatial data sets for each sub-indicator for 2015 to 2019. And we again are interested in calculating the proportion of population exposed to land degradation. I'm going to move this a little bit up, and again we have the chance to see our region of interest, and let's give it a name. Once we are done with typing the execution name and taking some notes, this time we're going to run this locally. So we're going to hit execute locally, and this is going to use the processing capacity of your own computer, of your own machine, to calculate the final SDG 15.3.1 indicator. So we can click here, and we're going to see that now this bar is telling us that QGIS is integrating all the sub-indicators into the final 15.3.1 indicator. And once this is done, it's going to show here under the datasets window. Right now it's still processing, so we're still waiting to see the final 15.3.1 indicator to show up here, which is going to take some time depending on the processing capacity of your computer. While we wait for SDG 15.3.1 indicator to get integrated, I'm going to show you how to add a base map to QGIS project. So here on Trends.Earth window, click on Datasets tab, and then here on the right lower corner, there's this option to load base map. So by clicking here, this window is going to pop up, And then we can select which country we are interested or we are running the SDG 1531. So right now I'm running it for Colombia. So I'm going to select Colombia, and I'm going to use all regions, given that that is our main region of interest. But of course, you can select the specific states, departments, if you would like to. And let's hit OK. So that's going to bring a map for the entire world, and we're going to see that here is focused in Colombia. So now that I've added my base map, I'm going to check if so SDG 1531 for Colombia is finished. So I'm going to load this data set to my map area. So let's click here and add the default layers to the map. So now we have it showing only for Colombia specifically. We just ran SDG 1531 using the subindicators that I calculated in just one step. But now I'm going to use the individual subindicators that we just calculated. So I'm going to click here under datasets. I have the subindicator representing soil organic carbon. So I'm going to add that to map. I also have the subindicator representing land cover, and also the land productivity subindicator that I calculated individually. So I just added those to the map. And now I'm going to go back to algorithms with a window and click again on indicator for SDG 1531, execute locally. Okay, once the window opens, we can carefully select which one you would like to use here. So here I'm using for land productivity sub, I'm matching it with the trajectory or trend. Here is the performance under performance field, and here's the productivity state under state. And also carefully select the land cover. So here I'm going to select Colombia land cover sub, and also here I'm going to select Colombia SOC sub for soil organic carbon. And I'm going to include also the population exposed to degraded land. So for now, I'm just running SDG 1531 using the individual subindicators for baseline. What I'm going to do, I'm going to give it a name. And execute it locally. In addition to SDG 1531 on land degradation, Trends.Earth also allows users to assess Strategic Objective 3 from UNCCD related to drought. By expanding this option on drought, we're going to see the two functionalities available. Let's execute remotely first. On this new dialog, you have the option to set up the initial year, the final year, and the lag of months that is going to be applied when calculating the standardized precipitation index, which is used to identify drought classes. We're going to follow the GPG on Strategic Objective 3 and use the 12 months lag. Here you can also include the JRC vulnerability index, and we can check that this is going to be running for Colombia all regions. Now I'm going to give it a name. Now that I've entered a name and taken some notes, I'm going to execute it remotely. Once the dataset on SO3 is done running on Google Earth Engine, we can add it to our map. And here we can see the maps representing drought classes for 2016, 2012, 2008, 2004, and 2000. And also the drought vulnerability coming from JRC, and the population data sets that were exposed, representing population exposed to each of those drought classes. Okay, so we can come back to algorithms window, and let's run now the drought vulnerability summary. And Trends.Earth is going to automatically recognize the data sets on SO3. So here we have the data set, the geospatial data set representing drought classes for Colombia. And here we have the drought dataset for vulnerability. I'm running it for Colombia or regions, and I'm going to give it a name. The summary on drought vulnerability is now done, so I can add it to the map as well. And here we have the data set representing population exposed to maximum drought, male and female for 2016 to 2019, and all the other data sets produced when running the summary. And we can also check the spreadsheet. This is going to bring the folder in your computer where Trends saved all the outputs. And we can click here on drought vulnerability. Once we are done calculating SDG 1531 for Colombia, in my case, and also the drought summary, we can create a zip file that is going to be ready for submission to UNCCD. So here, under Algorithms window, on the third option, UNCCD Reporting, we can expand this option and then hit on Execute Locally. And on this new dialog, Trends is going to automatically fill this field here with Colombia All Regions for SDG 1531, which also has the population exposed to degraded lands, so strategic objectives 1 and 2, 3 specifically. And here we have the data set for strategic objective 3 on drought. So I can check that I'm again running it for Colombia or regions, and I'm gonna give it a name. And then I can click on Execute Locally, and we can see that it's running now. So what we're gonna see here under datasets later on is that this UNCCD reporting package is gonna be done, and then we can click on Open Dataset Directory to check this data. In case you have datasets representing land cover, soil organic carbon, or land productivity that were custom for your area of interest, we can also import these datasets to Trends.Earth. So here on the datasets window, at the bottom, I'm going to click Import Dataset, and I'm going to see that I have the option to import an existing Trends.Earth output file, import custom productivity dataset, custom land cover dataset, or even a soil organic carbon dataset. I'm going to show you how to import a custom land cover for a tiny area in Colombia. So I'm going to click here in Import Custom Land Cover Dataset, which is going to bring this new dialog. Here you have the option to import a raster dataset, or even a polygon, a vector dataset, even in shapefile, KML, KMZ, or GeoJSON. I'm going to select the raster option, and I'm going to click on Browse to look for the dataset that I have in my computer. So here I have a Colombia land cover for 2000, dataset representing land cover classes, and I'm going to click Open. In case this raster was a multi-band raster, I would be able to select, but in this case it's just one. It has just one band, so it's automatically selected. I'm going to set here that this data set is representing land cover classes for the year of 2000. Or if you also have the option to modify the resolution in meters of this data set. I'm not going to do that. I'm going to leave it on the original spatial resolution. And here I'm going to have to match the original land cover classes or codes here to the land cover classes recommended by UNCCD. So I have a lookup table here from where I downloaded this custom data set, telling me that class number 3 on the original dataset represents tree cover. Input code 12 represents grasslands. 21 represents cropland. 22 represents other area, other land. 33 represents water. And in trends, minus 32,768 or 0 represent no data. I have the option to save this definition to my computer, so I can save it here as JSON. So then later on, I can just load this file in case when I'm importing the dataset for 2015, for instance, for calculating the difference between 2000 and 2015 for baseline. And then I can just save here. This is going to be representing the land cover, the matching of the land cover classes. And then I just decide where I'm going to save this. So, and then I hit save and I click in OK. This is going to tell us that Trends.Earth is right now importing, and it went super fast. So now we already have these imported land cover classes layer added to our map. And you can repeat that same step for the land cover classes raster representing the year of 2015. And you can do similar steps for land productivity and also for soil organic carbon when you have those data sets custom for your area of interest. In case you are interested in downloading some of the raw data that Trends.Earth uses when running all the default analysis, you also have the option to come here to Datasets window and click on Download Data. This is going to have you two options: download raw datasets or download the Land Potential Knowledge System and Land PKS data. So I'm going to show you how to download data used in Trends. Here we have land cover, soil organic carbon degradation, SDG, and the list goes on and on. So you can select any of these data, and then by clicking, for instance, if I'm interested in the standardized precipitation index for Colombia, given that my region of interest here in this exercise is Colombia, I'm going to click in SPI and then just click in Submit Download Request. This is going to tell us here up that this request has been submitted to Google Earth Engine, and then what we can do is check that this data is being processed in our server. This concludes our training. Make sure to visit Trends.Earth website for further details on the tool, and feel free to reach out to us with any further questions. Thank you.